Dear AS students or A-level students, we are continuing in M1 lessons, chapter of dynamics, chapter 3 in the M1 Excel book. Today we are solving problems, practicing. So we have classwork and homework, one question for homework for you to practice before we move to the next cases. So let's beginning exercising and practicing. We are in the case solving forces act on a smooth or rough inclined planes. This is that we are in. Yes? So we'll be starting solving the questions. We start with question number 1. The question says a particle of m5 kilograms slides down a smooth inclined plane that makes an angle at 30 degrees to the horizontal. So, before I continue reading the question from here, we are here. Sketch the question first. Draw it. So let's draw it together. He's telling me this particle of 5 kilograms slides down the plane, makes an angle of 30 degrees to the horizontal. This is the given. And the plane is smooth, is not rough. So no friction in this question. Find the acceleration part A, find the acceleration of the particle. Part B, find the normal reaction of the force or the normal action force, which is R. Before we start the questions, we said resolve the forces on the diagram. So this one is 5G cosine 30. This one is 5G sine 30. And R is here. Yes? So to do part A, only we have one force acting with the particle, which is this component of the weight. So we are in parallel to the plane. Stick with this concept. Stick with this logic in solving. 5G sine 30 is equal to MA. MG sine the angle is equal to MA, yes? By numbers, 5G sine 30 equals an MA. Solving for A now. In the calculator, A is equal to 4.9 meter per second squared. Part B, find the normal reaction between the plane and the particle. So we are in perpendicular to the plane. R is equal to only, in this example, 5G cosine 30, which gives in the calculator, calculate 42.4 to 3 significant figures. Yes? So this is straightforward. We'll be moving like in the difficulty level of problem. So straightforward one, then let's move to the one a bit different. Question 2. He's saying a particle is sliding down a rough inclined plane that makes 40 degrees to the horizontal. That makes 40 degrees to the horizontal. with acceleration of 3 meters per second squared. Find the coefficient of friction, mu. Notice in this question that he didn't give me the particle, the mass of the particle of mass m. He didn't give it to me. So when I sketch the question, I have to be aware of what I'm reading. So the angle 40, which is here, is given. Particle m, write it with m. He didn't give me the mass of the particle. And he said rough, so it's better to show the roughness like this. Good. And he said sliding down the plane with the acceleration. So it's better to assign this, label this on the diagram. So this is the direction of motion, and A is equal to 3. Then resolve the forces. So this one is mg cosine 40. This one is mg sine 40. And the resistant force, or the opposite, because friction, the direction slides down the plane. So the friction will be up the plane. It will oppose the main direction or the main force. And R, of course, the normal reaction force opposing mg cosine alpha. He wants mu in this question. He wants mu. To solve this question, it's different from the previous one and the previous examples we did. So let's do it. It doesn't matter if I start parallel to the plane. Most of examples or problems we start parallel to the plane before perpendicular. It doesn't matter. But in this question, m is not given. M is not given. So parallel to the plane, mg sine 40 minus fr equals ma. Perpendicular to the plane, r is equal to mg cosine 40. And the third one, don't forget this, fr is equal to mu r. Now what's the difference in this question? We are given A, yes, but m is unknown and fr is unknown. M is unknown, is not given, and fr is unknown. So we have two unknowns in the equations. I can't find r like previous examples. We can find r directly, m as unknown. So what's the best to do here? We have to do substitute equation into another one. This is the idea in these questions. So this implies that from mr here, fr is equal to mu times mg cosine 40. We substitute this one into here. Then by substituting fr in this equation into the main one, what it will give me? This implies what? Let's call this equation number 1. So back to equation number 1 now. What will happen to equation number 1? mg sine 40 minus this instead. Replace fr by this. Mu mg cosine 40 is equal to 3m, because we are given A is 3 in the question. A is 3 as shown here. Remember, we want mu. By factorizing for m, look how m will be removed. It will be gone now. Factorize for m common factor. What will have inside? G sine 40 minus mu g cosine 40 is equal to 3m. M with m with m will be cancelled. M equal, quantities on both sides will be cancelled. By solving this now for mu, easy to all of us, but I will be helping you, calculating with you. 9.8 sine 40. It's better to do this in the exam. 6.3 minus mu, then multiply 9.8 cosine 40. It will give you 7.51 is equal to 3. So 7.51 mu is equal to 6.3 minus 3. So mu is equal to 3.3 over 7.51 gives us 0.439 to 3 significant figures. It's good to solve. You don't know, some students might be confused in simple steps, so we'll have to do it in some questions. It's okay. All right, let's move to the next example. This example is a bit different also. It's a different idea. To solve together, let me just, I was writing here information, but I will write it together. Write it all together. A particle of mass of 10 kilograms moving down a rough inclined plane of an angle, or at an angle of 20 degrees to the horizontal, 20 degrees, that's like shown here, as shown in the diagram. So this particle at point A, is different language of questions. Part A, part 10 kilograms, is at point A, starts moving down the plane or sliding down the plane with initial speed v at A. This means initial, starts with the speed, leaves A with the speed of 10 meters per second. Continuing, passing B, v at B with 8 meters per second. Since, my dear students, the plane is rough, so the particle will be decelerating. Look, the initial is 10, then at B is 8. Because it's rough, friction is resisting the motion. So he said in part A, find the deceleration of the particle. Deceleration of the particle. Good. Before we start solving, resolve the forces. This one is 10 G cosine 20. And we have R here, FR here, because the main force, look where, which is what the main force? It's 10 G sine 20. 10 G sine 20. Then you start with the step that's needed to the part that he wants. This will help us in solving the question or the questions in the exams. Good. We are not given sufficient information here. FR is not given. He wants FR, mu not given. So I must remember the first chapter of formulas of motion. So that, you remember so that in the previous. And if, thanks for the students and serious students, they are subscribing the channel and communicating and sending comments and asking, which is I appreciate so much. So if some students hearing these videos and you don't subscribe, please, and if you need help in the previous chapter, I may do videos on it and solving, but already I'll be solving difficult, like a level of difficulty problems on chapter 2, which is on SOVAT, to find SOVAT, U and V and S and the acceleration using the formulas that you're supposed to memorize. So we are given here V at A, which is U. V at A, it's 10, which is U. U at A, the initial one. V at B is 8. And he gives us the distance between A and B is 5 meters, as shown. S is 5. He wants A. So you must remember which formula that. So remember that V at A, which is U, V at B, which is V in the formulas. But this is more convenient to write, more expressive, more clear to write. V at A is 10, V at B is 8, S is 5 meters. He wants A. So what's the formula that helps us in this, which is V squared is equal to U squared plus 2AS. V squared, which is V at B, and here at A. Yes? V at B is 8. V at A, which is U, it's 10, so it's 10 squared plus 2 times A times 5. By calculating, 36, or I don't do mentally, this is 64. This is 10 squared, with it, which is 100, so it's minus 100. Dividing by 10 gives you minus 3.6, which is A. Negative 3.6 meter per second squared. Nice. So sometimes, most of times, fortunately, questions come combined in one exams. They come combined. They combine the skills and the topics from different chapters. In part B, find the coefficient of friction, which is mu. We want mu in part B. To find the mu, you have to write what are we used to write. Equations of motion. Mu from where it will come? From here. So first, perpendicular to the plane. Perpendicular to the plane. R is equal to 10G. In this example, we can find I directly. So find it, calculate it. It's one of the most important skills in M1. Any quantity you can just find directly, find it. Find it. So R is equal to the three significant figures, 92.1 newtons. Parallel to the plane. Look and read the question well, down the plane, so write the equation well. So the main force is this, which is 10 G sine 20 minus FR is equal to MA. A is given now, which is 10 times minus 3.6. Be careful, replace it. It's deceleration. Be careful in here. So this is 10G sine 20. 10G sine 20 plus this, be careful, plus this. So calculate step by step. So FR equals what? FR is here, this plus this. So calculate 10 G sine 20, it will give off 36.5 to three significant figures, minus FR is equal to minus 36. So FR is equal to 33.5 plus 36. Which is 69. FR is equal to 69.5. and r is 92.1. So this implies that mu is equal to what? Fr dividing by r, which is 69.5 over 92.1, which is 0.755. Let me just write this to you more neat, to not be confused and to not see it well. So from here, Fr is equal to 69.5. So mu is equal to Fr dividing by r, which is 69.5 over 92.1 is equal to 0.755 to 3 significant figures. Part C, if the particle reaches the bottom of the plane, to C here, the bottom of the plane starts from here to C. When we say the particle reaches the bottom of the plane, what do you mean? It stopped. So V is 0. This is the first given information here. The particle reaches, starts from 10 here, starts with initial speed of 10 meters per second, reaches the bottom of the plane, which is 0. So you have U is 10 and V is 0. And we just found acceleration or deceleration. So A is equal to minus 3.6. What does he want? Find the length of the distance AC. Find the distance AC, which is S in our language. Yes, in mechanics formulas, we want S. So again, what's the formula that relates S with A, with U, with V? V squared is equal to U squared plus 2AS. V squared, which is 0 squared, U squared, which is 10 squared, plus 2 times negative 3.6 S. So this implies that this times this is 7.2. S is equal to 100. So S is equal to 100 divided by 7.2, which is 13.9 meters to 3 significant figures. This is the distance AC. It's not that hard like most of students or many students complaining from one. Do you agree? Do step by step, read the question, state the direction of motion, write the given information, my dear students, in every question, write the equations of motion, show the direction, use the calculator well, step by step, you'll find the answers. You'll be fine. Okay, I did the next question as homework for you. I give you the answers. Read the question and I give you the answers to check that, do I understand? So this one to you is, do I understand? Which is you, you're talking to yourself. Make sure that as a student, do you understand? Okay, I wish you can do this question, I hope. If you do this question, means you are starting solving problems to move on the next chapter and the next left part of this chapter and the next. Be moving like to harder problems. So make sure that you can do these ones. Okay, let's move to the next one, which is the last one, which is different from the previous ones. The diagram shows a box of mass of 2 kilograms is pushed up a smooth plane by, look here, horizontal force. by a horizontal force of 20 newtons. Horizontal, parallel to the horizon. Look at it. Parallel to the horizon. To the horizontal. And the plane is inclined at angle alpha to the horizontal, where tan alpha is 3/4. This question, if some of you studying at Excel, my main students that I'm doing this YouTube mainly for them, and I'm proud and glad for doing this. For the other students, if they have the M1 textbook for Excel, this is question 2 on page 55. Question 2, it's early in the exercise, but it needs to be explained. It needs to be explained. Focus here, this is the last example. When we say horizontal force, and this is the inclined plane makes to the horizontal, so this is alpha also by alternate. When we say horizontal, so this and this are parallel. So this and this are equal. So this is also alpha. This is alpha also. As we said in examples before, don't leave the force like this. Extend it, my dear. So extend it like this. So if this is alpha 2 again. By vertically opposite. By vertically opposite. So this one, this is 20 here. And again, this is inclined plane. So this 20 Newton does not affect the motion. What are the forces or components affect the motion? Its components. One adjacent, this is the angle alpha, and one what? Opposite or perpendicular. So this one is 20 cosine alpha. This one is 20 sine alpha, my dear students. And we have R here. And don't forget the natural components for weight. We have here 2g sine alpha, and we have here also 2g cosine alpha. Again, this 20 newtons is not clear. Enable yourself, make it easy to yourself. Extend the force like this, so it will be easier to resolve, to be seen. So this one is alpha, so this is alpha again. This alpha and alpha equal because they are alternate. This alpha is, or this angle is alpha because they are vertically opposite. So this is the adjacent, so it's 20 cosine the angle. And this one is the opposite, so it's 20 sine the angle. And we have the components of the weight, 20 cosine alpha like always. And this one 20 sine alpha, 2g sine alpha. What does he want in the question? In part A, he wants R. Find R, which is the normal reaction force. The reaction force. In part B, he wants A, the acceleration of the box. Good? That's the question once. Now we are given everything in this question but a different language. Before I write the equations of motion, we are given, focus here, since my dear students here, since tan alpha is 3/4, that will happen. This is alpha, this is 3, this is 4. Opposite over adjacent. Yes, O over A. So by Pythagoras, you are experienced in this as a student. This is 5. So sine alpha sine alpha is 3 over 5 or 0.6, and cosine alpha is the adjacent over the hypotenuse, 4 over 5, which is 0.8. So we know them. Then you come here to part A, simple like this. Solution, part A, R is equal to, look, it's easy, you make it easy to yourself now. You wrote, you resolve the forces in the diagram. So directly write R is equal to 20 sine alpha plus 2g cosine alpha. Then you just calculate 20 sine alpha is 0.6 from this triangle plus 2, 9.8 times 0.8, which is 27.7 newtons to 3 significant figures. To 3 significant figures. Part B, which is the last part for today. He wants the acceleration of the box. The question says, and just we read the question well, will be fine. Up, it was pushed or projected up the plane, so the main force is this one. So the main force is 20 cosine alpha minus 2g sine alpha is equal to ma. Some students or learners, my dear students, they say, when we write everything by cosine alpha and say we are wasting time. You are not wasting time, my dear students. Don't believe this thing. It's 10 to 15 seconds writing. It will help you. Then you write the next. Write it with the symbols, like with this notation. Then you substitute. So this is 20 cosine alpha 0.8. 2 times 9.8, 0.6 is equal to 2a. Then you calculate. Now you calculate. 20 times, which is 16, minus 2 times 9.8 times 0.6, which equals to 11.76 is equal to 2a. So a is equal to 2.12 meter per second squared. All right, my dear students, when you do write the equations of motion like this here, perpendicular to the plane, parallel to the plane, write them like this. Make sure you find sine alpha and cosine alpha from the question. This idea and this question that you have to calculate it, not given, easy to calculate. We may do this. Some people prefer to do or here. If this is, I say that this is easier. But according to our experience for years, some students were saying to me, when I teach physically, sir, why we don't do this? Alpha is equal to tan inverse 3 over 4, which is 36.9 when you do it. Then sine this is 0.6, you get the same answer. I don't agree with decimals and this way. It's right, it's not wrong. But this is, especially you'll see in the next videos, what do I mean? Especially when you are given proof that or show that. If you write with decimals, you confuse yourself. Students, good students that I teach or I don't teach, my dear students, they did very bad. They are A to A star in O level. They did E. They did E. We got E in January, M1 exam in January. Some of them got less than E. They got U. So A star, if he get D is bad. What about E and U? Because 2 to 3 questions we can say they came with symbols, prove that, no numbers. So you have sometimes in the questions to prove, to show every step I do with symbols, with letters, with variables, not so we don't come to the calculator so much in solving problems with M1. As usual, I hope you understand well. If you don't communicate, please. But I decided to do problems before moving to the next cases. It's good to practice first and make sure you can do the homework. It will help you. Of course, I will give you homework, past paper problems in the future, but when we finish the cases, let us finish the cases first in chapter 3. Then we'll be practicing many problems. Don't worry about this. Dear students everywhere, thank you so much.